Have you ever wondered how hard gelatin capsules are made and what standards they must meet? Well, you're in for a treat. Hard gelatin capsules are a cornerstone of the pharmaceutical industry, delivering everything from vitamins to life-saving medicine in an easy-to-swallow form. They are more than just a convenient delivery system. The formulation, filling, and quality control of these capsules are a meticulous science, governed by stringent standards to ensure their safety and effectiveness. This video will take you on a journey through the creation of these capsules. We'll delve into the step-by-step formulation of hard gelatin capsules, explore the volumetric and dosator principles in capsule filling, and uncover the quality control standards they must adhere to. We'll also highlight common defects and the remedies thereof. By the end of this video, you will have a complete understanding of how hard gelatin capsules are made and the standards they must meet. The formulation development of hard gelatin capsules involves several key steps. Each step is a crucial part of the process, and understanding them can provide insight into the world of pharmaceutical manufacturing. So, let's dive in. Our journey begins with the selection and preparation of raw materials. This is an essential first step, as the quality of the final product is largely determined by the quality of the materials used. The materials typically include gelatin, water, and a plasticizer, such as glycerin or sorbitol, for flexibility. These ingredients are carefully measured and mixed together under controlled conditions to ensure consistency. Next comes the process of gelation. The mixture is heated until it forms a liquid, which is then cooled to form a gel. This gel is the basis for our capsule shell. Achieving the right consistency in this stage is vital, as it affects the strength and stability of the final product. Once the gel is ready, it's time for the dipping process. Stainless steel pins, shaped like the desired capsule, are dipped into the gel. The gel adheres to the pins and, as it dries, forms the shape of the capsule. This step needs to be controlled meticulously, as the thickness of the gel layer determines the strength of the capsule. After the dipping process, the formed capsules are then stripped from the pins and cut to the appropriate length. Now, we have our empty capsule shells ready for the next stage, filling. Filling the capsules is a delicate task that requires precision. The fill material, usually a powdered or liquid medication, is carefully measured and deposited into the bottom half of the capsule. The top half is then placed over it, effectively sealing the medication inside. The filling process can be done manually for small quantities, but in a large-scale production, semi-automatic or automatic equipment is typically used. The final step in the formulation development is the sealing of the capsules. This can be done either by banding or by heat sealing. Banding involves applying a thin layer of gelatin solution around the joint where the two halves of the capsule meet, while heat sealing fuses the two halves together using heat. Both methods provide a secure seal to prevent leakage of the fill material. Quality control is an ongoing process throughout the entire formulation development. Each stage is regularly monitored and tested to ensure that the capsules meet the required pharmaceutical standards. This includes checks for uniformity, strength, disintegration time, and freedom from defects. And that's how hard gelatin capsules are formulated, a process that requires meticulous attention to detail and strict adherence to pharmaceutical standards. From the selection of raw materials to the sealing of the capsules, each step plays a vital role in ensuring the quality and efficacy of the final product. It's a fascinating journey, isn't it? And remember, this is just one aspect of the vast field of pharmaceutical manufacturing. There's so much more to explore, so stay tuned for more insightful content. Subscribe for more because you won't find me later. Now that we know how hard gelatin capsules are formulated, let's explore the principles behind capsule filling. In the pharmaceutical industry, accuracy and uniformity are paramount. The two widely used principles to achieve this when filling capsules are the volumetric and dosator principles. Let's start with the volumetric principle. As the name suggests, this principle is all about volume. The filling machines that use this principle are designed to deliver a precise volume of powder or granules into each capsule. This process starts when the powder is poured into a reservoir. The machine then picks up a specific volume of this powder and dispenses it into the capsule. The amount of active ingredient in the capsule is controlled by the volume of powder or granules, which is determined by the size of the space inside the machine that picks up the powder. On the other hand, the Dosator principle, which is a bit more complex, uses a plug of powder. The machine, equipped with a dosator and piston, first gets filled with powder. The dosator is then moved to the capsule, and the piston pushes out the powder plug into the capsule. The amount of active ingredient is controlled by the weight of the powder plug, which is determined by the depth to which the piston goes into the dosator. Both principles are designed to ensure that each capsule contains the correct amount of active ingredient. They are crucial in ensuring that the medication is safe and effective. However, the choice between the two often depends on the properties of the drug formulation. Some formulations are better suited to the volumetric principle, while others work better with the dosator principle. These principles are crucial for ensuring the efficacy and safety of the medication contained in the capsules. However, it's important to remember that these are just two of the many facets of capsule filling. It's a complex process that requires a deep understanding of both the principles and the practical aspects of pharmaceutical production. Quality control is a critical aspect of capsule formulation. Let's delve into the standards and common defects in this process. Quality control is the cornerstone of pharmaceutical manufacturing, ensuring that every capsule is safe and effective for consumption. These standards are set by several international bodies, including the Indian Pharmacopoeia, IP, the British Pharmacopoeia, BP, and the United States Pharmacopoeia, USP. They provide a comprehensive set of guidelines to maintain the quality, purity, and strength of each capsule. The Indian Pharmacopoeia, for instance, sets the standards for pharmaceutical substances and their formulations in India. It includes tests for identity, purity, and potency, among others. Similarly, the British Pharmacopoeia provides a standard for medicinal substances outlining the required physical and chemical properties, methods of analysis, and storage conditions. The United States Pharmacopoeia, on the other hand, is a compendium of quality specifications for drugs and dosage forms, including hard gelatin capsules. Now, let's explore the common defects that can occur during the formulation process and how they can be remedied. One of the most common defects is the splitting of capsules, where the capsule shell breaks apart. This can be due to several reasons, such as inadequate moisture content in the capsule shell or excessive pressure during the filling process. To remedy this, it's crucial to maintain the correct moisture content and avoid applying too much pressure when filling the capsules. Another common defect is dimpling, which is when the capsule shell develops small depressions. This is usually caused by excessive moisture or heat during storage. To avoid dimpling, capsules should be stored at a controlled temperature and humidity level. Leaking is another defect that can occur where the capsule contents seep out. This can be due to a poor seal between the cap and body of the capsule, or the use of inappropriate filling materials. To prevent leaking, ensure a tight seal between the cap and body, and use appropriate materials for filling. Finally, cap locking is a defect where the cap of the capsule fails to lock onto the body. This can be caused by overfilling the capsule or using a shell that is too small. To remedy this, ensure the capsule is not overfilled and that the correct size shell is used. To sum it up, quality control in capsule formulation involves adhering to international standards and promptly addressing any defects that arise. It's a meticulous process, but a necessary one to ensure that every capsule is safe, effective, and of the highest quality. Ensuring quality control and addressing defects promptly are key to producing safe and effective hard gelatin capsules. We've covered a lot of ground today, from the formulation development of hard gelatin capsules to quality control standards and defects. We delved into the intricate process of developing these capsules, understanding the role and importance of each step along the way. We also explored the principles of volumetric and dosator in capsule filling, shedding light on how these principles ensure precision and consistency in dosage. We then navigated through the high standards of quality control as per IP, BP, USP, and the potential defects that can occur. We offered insight into the challenges that can arise during the capsule filling process and the remedies to address them. It's a complex world, but with every question we ask and every answer we seek, we're becoming masters of it. Subscribe for more because you won't find me later. Until next time, keep asking questions and seeking answers. Knowledge is power.